Good afternoon. Today we are going to see about graphs, which is a important topic and very interesting topic in data structure. We are going to see from the definition itself. Then, what is meant by graph? A graph is a finite set of nodes with edges between the nodes. That is, formally we are representing a graph using the structure called v comma e. V represents the set of nodes which is available in the graph, and e is the subset of the nodes which is in the total nodes available in the graph. That is the e which is used to form a connection between the nodes in the graph, which is used for representing whether the two nodes having the connectivity or not. By using the parameter e, we can identify that. Okay, this is an example diagram for the simple graph. We have formally we have a four nodes which is available in this graph, that is 0, 1, 2, 3, and 4. Here, what does the E represents? If there is a connectivity among the 0 and 1 nodes in the graph, means we have representing 0 comma 1 over there. That is we are representing the subset of the nodes which is available in the graph. Then if there is a connectivity between the 1 and 2, means we are going to represent 1 comma 2 over there. Likewise, we are going to represent. Oh, real life, if we are going to relate the graph to a real life example, if you want to show the relationship among the persons in the home or house, or if you want to know the if you want to connect the different cities on what is the thing we are going to whether there is a connection whether there is a connection between that, we are going to, if we want to represent that, means we can easily using the graph, we can represent that. Okay. For example, if you are considering the six people, for example, in this example, John, Mary, Joe, and Helen, and something respectively, they have a age 12, 15, and 12. And if you want to show the relationship, that is the John is younger than Mary, or Joe is small elder than Helen. If you want to show the relationship like this, or if John is a brother for Mary, or Joe is the sister brother for Helen, if you want to show the relationship like that, means we can easily represent using that graph. So we have to likewise we have to relate this real life examples to your subjective nature. Okay, then what is how to represent the graphs? We are going to how to represent means, we have, if you want to relate that, if you want to represent how to represent the nodes, or how to what is the relationship among the node, means we are going to represent using two types, that is adjacency matrix representation, another one is adjacency list representation. Okay, what is the adjacency matrix? If you are considering the matrix, means we are going to represent the elements in rows and columns. We already know about that. And how then, what is the next condition? We have to find we have to know about the how many number of rows and columns we are going to represent using matrix. So how to identify that? We have to identify number of nodes available in the graph. If we having four nodes available in the graph, means we have four rows and four columns in our matrix. Okay, we have a five node, means five rows and five columns. Likewise, if the number of it is depends upon the matrix size, is depends upon the number of nodes which is available in the graph. Then how to fill the how to fill the matrix, we are going to see. Then this is the diagram sample graph. We have already discussed, we are having the five nodes which is available: 0, 1, 2, 3, 4. We are giving a name to the node as 0, 1, 2, 3, and 4. We may give the name as a b c d, or we may give as a Joe. Likewise, in your previous example, I Joe, Helen. Likewise, you can assign whatever the names you wish to your nodes in the graph. Okay, here, how many number of nodes? We have five nodes, so we have a five rows and five columns. Okay, then how to fill the matrix? That is, we are going to fill the matrix using the condition. That is, if we have a relationship between if we have a connectivity between the two nodes, If there is a connection between 0 and node, between node 0 and 1 means we are going to fill that place with 1. Yes, obviously we are filling with that value is 1. If there is a connection between 0 and 2, no, there is a no direct connection between 0 and node 2. So we are going to fill with that 0. If there is a connection between 0, if there is a direct connection between 0 and 3, yes, it is having a direct connection between 0 and 3. So we are going to fill with 1. Then again we are going to, if there is any direct connection between 0 and 4. No, if it is the case, no, it is not at all. So we are going to fill with that 0. Again you are going to consider the node 1. That is node 1. From node 1, if there is any connection between 0, 2, 3 and 4, likewise we have to fill the matrix. Okay, this is another example. For example, in your previous example, we are naming the nodes with 0 and 1, 2, 3, 4. Here I am naming the nodes with Mary, Helen, Joe, John, Tom and Paul. We are naming like this. We have how many number of nodes here? We have only here nearly we have a 6 nodes available here. So we have a 6 rows and 6 columns. How to fill that? If there is any, for example, if you are considering first row is filled based on the node 0, that is node 0 is Mary means, if there is, we have to find if there is any direct connection to Helen, if there is any direct connection to Zoe, if there is any direct connection from Mary to John, if there is any direct connection from Mary to Tom, if there is any direct connection from Mary to Paul. If there is any direct connection means you have to fill with that place with 0, with that place with 1. There is no connection means you can fill that place with 0. Then what is the advantages and disadvantages of if you are using if you are representing the graph using matrices means, it is obviously it is very simple to implement as well as very easy to understand. And what are the disadvantages means, if the number of nodes in the graph gets increased means the number of the time taken as well as the memory required to fill the matrix is very high. This is the disadvantage of the matrix representations. And what is another way for representing the graph? That is adjacency list representation. We are going to represent the number of nodes which is by using the linked list. What does meant by, we have already know about the linked list. How to represent the linked list? We have a link, when our linked list means we have a two types of part. One is the data part, another one is the link part. Okay, we are one dimensional array which is used to represent the nodes available in the graph. Example like this example shows how it depicts the how the representation has been done. That is, we have a 5 nodes or 0 to 5, there is 6 nodes available. For list 0 is empty. Why the list 0 is empty means there is a no direct connection between Mary to all other nodes in the graph. That is Helen, Joe, Palan. There is a direct edges. That is means the direct edges, the arrow mark is towards that particular node. That is the edge, arrow mark towards Joe or arrow mark towards Helen. Here no arrow mark towards Helen and Joe from Mary, so that is the list is empty for Mary, then Helen also. What is if you are having John? If you are considering the John, there is a direct connection to Mary, there is a direct connection to Tom, there is a direct connection to Helen and direct connection to Paul also. So we are going to represent, there is a direct connection to Mary, so we are going to represent as a what is the element which is used to represent Mary? 0. There is a direct connection to Helen? 1. There is a direct connection to Tom? 4. There is a direct connection to Paul? 5. Likewise. This is compared to matrix represented. This is this is also easier to implement, as well as the memory requirement for this representation is very low compared to previous representations. Okay. We are going to next. We are going to see about the what are the different types of graphs. Where the graph is mainly classified into two types. That is directed graph. Another one is the undirected graph. Directed graph is also known as the digraphs. There is the direction of edges is a important thing in the direction graph or directed graph. Edge direction, whether it point towards or point outwards. Then, if next second one is the undirected graph, there is no direction of arrow mark between towards or outwards. There is no direction mark in the edges. If it is like that, that is called as the undirected graph. Okay, this is an example for undirected graph. For in your example, Mary, Helen, John, and four nodes are available. There is no arrow mark direction which is representing between the connectivity. There is a node arrow mark. So if obviously Mary is connected to Helen, Helen is connected to John, as well as Mary is connected to Joe, likewise. Based on the graph connectivity, we are going to classify whether the graph is connected or disconnected. If all the nodes, that is in your undirected graph, the graph connectivity is mainly discussed in the undirected graph. If undirected graph is connected, means every pair of the nodes is connected. Every pair of the nodes in the graph has to be connected, means that graph is said to be connected. If it is, if the node, if one node is disconnected from that, or the two nodes is separate from the particular graph, means that is called as the disconnected. Thanks, the separate, if the two nodes are separate from the previous, if we have already we have a six nodes, the four nodes are already connected, the remaining two nodes are separate from that, it is the distance from that graph, or distance from that node, there is no connectivity between that node, means there is a, the graph is said to be divided into two parts, so that it is obviously is called as the disconnected graph.